In today's video, we're going to look at the applications of impulse in our everyday lives. So one of the guiding principles in applying impulse in our everyday lives is this statement here. If the momentum changes over a longer period of time, then the net force experienced will decrease. Right, so we have this relationship here from Newton's second law in terms of momentum, as you might recall. Now, the net force is equal to the rate of change of momentum. So we also saw that the relationship between net force and time is that net force is inversely proportional to delta t. This means that if you have a bigger delta t, or rather if the momentum changes over a longer period of time, then the net force experienced here will actually be less, or it will decrease. But if our change in time decreases, so if our delta t is to decrease, our net force will increase, or the net force that is being experienced there, right? So the momentum must change over a certain period of time, and the longer it takes for the momentum to change, the longer it takes for the momentum to change, the less the force that is actually required for that momentum to change. The less the time taken for the momentum to change, the greater the force that is going to be experienced during that change. Okay, for momentum to change, a net force is required. So the size of that net force is going to depend on the amount of time that is taken for that net force to act in order to change the momentum. Okay, so this is the relationship between net force and contact time. So this will hold true if you maintain the delta p to be constant. All right, now let's look at some of the applications here. The first application that we'll look at is the use of airbags in cars. So during a collision, an airbag inflates and occupants collide with airbags instead of the dashboard. Thus, the time of contact will increase, and hence the net force decreases, since the net force is inversely proportional to time while the delta p remains constant. So let's just suppose that you're in a car and the car gets involved in a head-on collision. All right, so if this happens now, an airbag is going to be deployed. So once an airbag is deployed, the occupants of the car here are going to collide with the airbag. Now, the reason why this is very safe during a collision is simply because the momentum of the occupants of the car must change over a longer period of time. Since you will collide with the airbag instead of the dashboard, your momentum will change over a longer period of time. It will take time for you to come to a stop. So the greater the time taken here, the less the net force that is going to act on the occupants of the car. So there'll be less injuries that is going to be experienced by this person. But if this airbag was not there, the person is going to hit on the dashboard, and the time that it takes for that person to stop will actually be less, will reduce. So that will cause a greater net force to act on the occupant, and hence chances of injuries will actually be greater. So this is how you would respond to such a question. If a question says, what are the use of airbags in a car? We need to explain it in this scientific manner. So you also have to write this expression here, and you also have to mention the fact that the contact time will increase. So the main aim of airbags is to increase the contact time, which reduces the net force, since the F net is inversely proportional to time, while the delta P remains constant. Right, we also have what are called crumble zones. A crumble zone is that front part of the car or the rear part of the car which is designed to crumble during a collision. So each and every car, these modern cars have what are called crumble zones. So the front part and the back part of the car, they are called crumble zones. Okay. They are designed to crumble during a collision. So what's so important about crumble zones? During a collision, the crumble zone increases the time over which the momentum changes. So we can see that there's an increase in the contact time. This reduces the net force that is acting on the car and the occupants. So the net force is going to be reduced since the net force is inversely proportional to time while the delta P remains the same. So we are pretty much explaining it the same way as we did for airbags. Okay. Right. Catching a cricket ball. Right. So when someone throws something like a cricket ball or a heavy object towards you, what do? The cricketers lower their arms as he or she catches the ball so that the contact time between the ball and the hands increases. So they have to lower their arms as they receive the incoming object. The reason why they do that is simply to increase the contact time here. If they do that, the net force experienced will be less, since the net force is inversely proportional to time while the delta P remains the same. So the aim again is to increase the contact time, which reduces the net force. Okay, since these two are inversely proportional. So the net force is the one that they want to reduce because it is the one that can cause injuries. If they don't stretch out their arms and follow through as the ball falls into their hands, then they might get hurt in the process. Okay, so there are so many examples that you can look at. I encourage you just to go and research. Bending the knees as you land from a jump. Why do we bend our knees as we land on the ground after jumping from a certain height? Why do you have to bend your knees as you land here? You do that so that you can increase the time over which the momentum can change. And once you do that, the net force that you're going to experience is less, so there are less chances of injuries there. Right? Okay, so go and find out more. Why do we bend our knees? Why do we follow through when you're hitting, let's say, a tennis ball with a racket? What are the use of what are called track arrestor beds? Why do we lean forward when you're throwing a javelin? So these are some of the examples here of how we use impulse in our everyday lives.